Hi everyone, welcome back to my YouTube channel. Today we are solving one of the most asked in coding interview questions, that is the two sum problems. The problem is asked by Google, Amazon, Microsoft and Facebook, and almost in every product based company. We will solve it in C++, starting from the basic brute force approach and slowly moving towards the most efficient optimized solution. We will also understand each problem with clear and detailed examples. So let's start with the problems. What is the two sum problems? Basically, we have given an integer array of nums, and we have given an target integer, and we need to find the nums of I plus nums of j equal to target, and we need to return the indices of the element. Examples I'm taking, we have 2, 7, 11, 15 and target is 9. So we need to return the indices of the element that is equal to target. If we are taking this example, we have 2 and 7s, that is equal to 9. So we need to return the 0, 1 because the indices of 2 is 0 and indices of 7 is 1. So we need to return the indices of the element that is the adds up to that target. So most important, three important point I am explaining here. The first one is we need to return the index, not the value. Don't return 2, 7, that is incorrect. Second is we have only one valid pair. We have 2, 7, that is equal to 9. We will not find any element like 4, 5 that is equal to the target because we have already one pair. If 4, 5 is there, 2, 7 will not be there in this array. And the third is we need to return the indices that must be the unique, that should not be the same. Let's suppose we have the target 4, so don't return 0, 0 because 2 plus 2 is 4, so don't return 2, 2 0, 0, 0. 2 plus 2 is equal to 4, so we need to take care about that. So I am talking about the approach first. First we will do with the brute force problem. What we will do in this problems, we will check every possible pair using two loops. Okay, for each element we try all remaining element, and if the pair ups to that target, we will return the indices. How I am explaining: if we have nums equal to 1, 4, 5, 11, and if we have target equal to 15, so what we will do here, we will check all the pairs. If we are taking I equal to 0 to, so if we are taking I equal to 0, so nums of 0, that is 1. So we will compare this all element with the array nums of 1, nums of 2, nums of 3 and nums of 4. So if we are taking the first element, and nums of 0 is 1, so nums of 1 is 4. 1 plus 4 equal to 5, that is not up to the target. Second element, second indices element, that is 5. 1 plus 5 equal to 6, that is not up to the target. And the last element, that is 11. 1 plus 11 equal to 12, that is not up to the target. When I equal to 1, then our nums of 1 equal to 4, so we will check another with 5 and 11. 5 is 9 and 11 will be the 4. We will check with the 5. In the 5 it will be the 9, that is not the solution, and we will check with 4 with 11. So 4 plus 11, that will be the 15. So we found our solution. What was the indices of the 4? That will be the 1, and indices of the 11, that will be the 0, 1, 2, 3, 1, 3. So here we will return 1, 3. Okay, you found that the for the each and every element we will run the loop from I plus 1 to for I plus 1 to n. For I equal to 0, we will run I plus 1 to n minus 1. Okay. So I already written the solution for this brute force method as well as optimized solution. So we have given the integer nums and the target, and firstly we will find the length of the given array. Okay, so for I equal to 0, we will run the loop from I equal to 0 to n, and for the j we will run another loop j equal to I plus 1 to n. And if we found nums of I, nums of the element, and nums of j equal to target, we will return the indices of the element and nums of I comma j. Oh, and if we don't find any solution, we will return the empty indices. Okay, so I think you understand that the problems is very easy, that for each and every element we will run the loop from I plus 1 to n minus 1. And if we found the solution, we will return the I plus 1 indices of the element. So that will be the I comma j. Okay. So here is the brute force solutions. So here the brute force solution, we will return we are writing the two loops for the time complexity, that will be the big O of n square. Okay, and the space complexity will be the big O of n. So the solution is very easy to understand. The problem is that this is very slow, because we are writing the two loops. If we have big like 10,6, then it will very costly. So we need to find the efficient approach. So another efficient approach, we can solve these problems using HashMap. Okay, in HashMap, what is the idea of this? So what we will do, while iterating of the each number of x, 2, 7, 11 and 15, while iterating each number of x, we will compute the searching element. How we will compute the searching element? Searching element will be the target minus current element x. Okay, if this searching element is present in our map, we will return the indices of this already present element and the this current element. Okay, if yes, we will do this. Otherwise, we will store the current element with the indices in our HashMap. Okay, so let's understand with this example how we will do this. Let's suppose we have current number is 2. So our searching element will be the 9 minus 2. If our target is 9, so our searching element will be the 7. We will search this 7 in our map. If we don't find this 7 in our map, that means this element is not present in our map. So what we will do, we will store this current element with this indices in our map. So we will store 2, 0 in the map. Now we will come to the 7. So our searching element will become, target is 9 minus current element x, that is 7. 9 minus 7 is 2. So our searching element in the map will become 2. Now we will search this element in map. So as soon as we find this element, we will return this element's index, that is 0, and our current element index will be the 1. So we will return 0, 1. Okay, so our this time complexity will be the big O of n, or space complexity will be the big O of n, because the searching cost is in HashMap is big O of 1, and we are iterating this for each and every element. As soon as we find the solution, we will return the we will return the value. Okay, so I have already written the solution for HashMap as well. So what we will do, we have functions to sum and we have target. I am computing the length, and we have declared an unordered map with int comma int. That's first int is for the numbers, and the second int for the index. Okay, so we will run the loop from 0 to n, and our searching element, how we will find the searching element, that will be the target minus nums, because we are how this will we are getting. Let's suppose if we are x plus y equal to target, and I am saying that the x is our current element. So what will our searching element will be? The searching element will become target minus x. So if we find our y, then we can say that if we find this in y, so we can say that the x is already present and y is present, so that will adds up to the target. Okay, so if we find searching element, we will find this searching element in the map. How why we are writing this mp.end? What map do if we don't find this searching element or any element in the map? It returns mp.end, this function, this pointer, mp.end pointer. So we are writing here not equal to, that means the element is already present in the map. So if the element is already present in the map, we are directly return the mp of searching element. If we are returning the map of the searching element, this is the index of searching element, comma I. mp of se returning this index of the searching element, and comma I is the current element. So we can write solution in any 0, 1 or 1, 0. That will not be the problem. So we can return the indexes in any order. Okay, and if we don't find any solutions, we will store the value and index in the map. And if we don't find any solution, we will return the empty solution. Okay, so the time complexity will be the big of n, and the space complexity will be the big of as well, because we are storing the each and every element if we in the worst case. So you can compile this solution in your LeetCode problems. That is the first problem. I am giving this video link, questions link in the description as well. So that's for the today. We have covered the two sum problems from basic to highly efficient solution with the examples. If this helps you, please like, subscribe and comment which DSA problems I should explain next. See you in the next video. Thank you.